Let me check it here. Can someone confirm if my audio and video are both proper so we can get started? Good evening, Sandeep. So let's get started. Okay, so this session would mainly be about BFS and DFS. And I'll be so this would be a different stream than what I previously used to do. So previously I used to write code on the slides only. So but in this class I will try something different, and I'll try to code the solutions along with you guys. Okay, so that actually gives a better view. Okay, so and that is also I think easier to understand for most of you. So in this session mainly we'll be focusing on BFS and DFS on graphs. Okay, and our main focus would be on problem solving. Okay, and just in the start we would discuss what BFS and DFS are. In a very brief manner, I have already discussed both BFS and DFS in my last lecture on the. Okay, so before we start, let me tell you about the few batches that are going on at Unacademy. So the first is the Yoddha batch, which are a batch for intermediate to advanced programmers, in the Lakshya batch and the Luna batch. Okay, so Luna batch, if you plan on learning Python, then you can join the Luna batch. And if you plan on learning competitive programming, then you can join the Lakshya. So Dona batch is a 11-month batch, and Yoddha and Brahmas batches are actually 6-month batches, and Lakshya batch is a 5. Okay, so all of these batches have already gone live. So apart from this, there are batches for system design, computer fundamentals like operating system, database management, computer networks, yeah, and as well as courses on development, which include backend development as well as full stack development. So all of these batches have already gone live as well. So the first system design and the computer fundamental are 2-month courses, and backend development and full stack development are actually 4-month courses. So if you take the subscription of any educator of the competitive programming category on an academy, then you would get access to the content by all of the educators. Okay, and this would like help you perform well in contests like Google Kickstart, Google Coach, okay, as well as lithium ICT. Okay, and this would also help you crack interviews at good product company, and you would also be receiving a certification. So there would be live interactive classes as well as relevant practice problems from question would be solved, as well as one very nice thing about the subscription is the doubts. Okay, so whenever you are stuck, you can reach out for doubts and your doubts will be solved as quick as possible. Okay, so the original price of the course is actually 33,000, but if you use my code Anuj10, then you would get a discount of 10%. That is a discount of 3.3 thousand, and you would get it at 29,700. Okay, so as like if you ask me personally, then I think you should go for the 6-month or the 12-month batches, and especially the 12-month batch since it is actually more money efficient. And if you take the subscription for the 6-month and 12-month batch, then you can avail a no cost EMI. Okay. So apart from this, there is also a bug bounty program that is going in. So if you find anything inappropriate in the video, then you could report and claim a price. So let's get started. Okay, so first I would just very briefly explain what BFS and DFS are. Okay, and then we would directly go on to problem solve. Okay, so let's see DFS. Okay, so suppose these are the nodes in my graph. So suppose this is my graph. This is 1, 3, 4, 5, and I start from this node. Okay, I need to apply DFS. So DFS is basically a depth first search. Okay, and BFS is a breadth first search. Okay, so in DFS we actually go on. So we start from some node, then go to its child node, then from that node we go to its another child node till we run out of nodes. Okay, so the first node that I actually go to is 1. Okay, then I have two options. Either I can go to 2 or I can go to 3. Since the node 1 are actually two children, 2 and 3. So suppose I go to the node 2. Okay, now again I see that like there are two nodes connected to it, so first node and the third node. Okay, but we have already gone to the first node, so there is no use of going to the first node, so we go to the third node. Okay, so suppose now I come over here. Okay, so till now I have traversed the first node, the second node, and the third node. Now the third node, how many nodes are actually connected to it? This is the node number 1, and the node number 2 and node number 4. But node number 1 and node number 2 have already been visited, so I won't be visiting those nodes. I would go to node number 4. Okay, so I would visit this node. Then again I would say the same thing, that 4 is actually connected to three different nodes, 3, 5 and 6. Okay, but we have already visited 3. Okay, so I can go either to 5 or either to 6. I can randomly select any one of them. So let us say I go to 5. Okay, so now I have gone to 5. So now I will again check for 5. So 5 is connected to 4 and 6. But 4 has already been visited, so now I will go to 6. Okay, so now at 6, when you see that none of the nodes are actually unvisited, so we stop our DFS at this point. Okay. Can we discuss the Pacific Atlantic water flow problem after this? What problem is this? I haven't actually seen this problem before. Okay, so that's all about DFS. Okay, and let me write the code for DFS as well for you guys. So if you see that we actually start from some node U and see what all nodes are connected to it. Okay, and then whichever node we find that it is not visited, so we go to that node. Okay, and then do the DFS over there. Okay, so let's get started. So I'll be using IDE 1E. Okay, so let me just clear everything. Okay, so let us assume that there are, let us say, is this clear to you guys, or should I zoom it up a bit? I think it would be clear now. Okay, so let us assume that there are maximum 1000 nodes in my graph. Okay, and I declare I'm using the adjacency list representation to actually denote my graph. So Pratik, yeah, we can see that problem after this. Okay, so first I would be taking how many nodes are there in the graph. So let me declare global variables only, since it is easier to code and we don't need to pass things as in the form of functions. Okay, so the first thing that I took was how many nodes are there and how many edges are there. Okay, and then I take input all of the edges. So let u and v denote the edges. So let I just add the edge for both in the adjacency list of both u as well as v. Okay, and then I'll also be having a array, visited array, to check if the node has been visited or not. So I'll just initially assign it to mention 0 size of visited. Okay, then I'll just call DFS, and let us say I start my the start node for DFS is actually the node number 1. Okay, so let me write DFS now. So suppose I am at node U, then I can just traverse the adjacency list for U. For int I equal to 0, I less than adjoint of u dot size. Okay, I plus plus. Okay, then I'll just check that if, okay, so let me store this over here, so I don't have to write this thing again and again. Okay, so if this node hasn't yet been visited, then I'll simply call DFS on it. Okay, and here I have visited node U, so I'll just mark it's visited as well. Okay, and we can just try printing it the nodes over here. Okay, so this is what the code would look like. Okay, let me just run it on the same example as well. Okay, so there I think we had, I guess, let me check quickly. 1, 2, 3, 6 nodes. One was connected to 2. Okay, okay, cool. So we had 6 nodes, and I think 1, 2, 3, 4, 7 edges there were. Okay, and one was connected to 2, one was connected to 3, and 2 was connected to 3, 3 was connected to 4, 4 was connected to 5, and 4 was connected to 6 and 5 was connected to 6. Let me just check once. 1 is connected to 2, 1 is connected to 3, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5, 4 is connected to 6, and 5 and 6 are connected. Cool, and there are 7 edges. Okay, so let me just run the code. Let me also copy the code once so the code doesn't go away. Since on IT1 sometimes random things happen. Okay, so you can see 1, 2, 3, 4, 5, 6, and that was the order that we did it. Okay, so this was actually first node that we created, then this, then this, then this, then this, then this. Okay, but however, you guys know that we can actually visit 1, 2, 3, 4, and we can visit 6 first and then 5. Okay, so that's not a problem. That depends on how you have stored the nodes in your adjacency list representation. Okay, but I think the idea is clear to you guys, right? So just write a yes. So I will ask a question on this. Just write a yes if the code as well as the problem is like as well as DFS is clear to you guys. Okay, yeah, so it is clear. So tell me one thing. You guys can see this code, right? Can you guys tell me what is the problem with this code? What is the problem? There is some problem with this code. Okay, and you guys need to figure out what is the problem. And I have actually taught you how you can what is the correct code for DFS. So try figuring out the problem. It is a very small mistake that we often miss out. So any idea what's missing in the code? The code is visible to you guys, right? Or should I zoom a bit? So try finding the mistake. The mistake is very small, but it could give you a wrong answer. We are marking in main function. We have to check for all. Yeah, correct. Pratik is correct. Please solve this. I want to read one from an. Okay, so Atishay, please write it at the end. Okay, so I think there are two questions. One Pratik gave you Pacific Atlantic problem. We'll solve that and we'll solve your problem. Okay, but let's just discuss that at the end. So Kushal, clear with. Okay, no, not clearing the vector. The only thing that needs to change is see. See something. Suppose this is your graph actually. Let us say this is 1, then this is 2, this is 3, and let us say this is 4, 5, 6, 7. In this graph, if you call your DFS on 1, then only these nodes would be visited. But there are other nodes in the graph also, right? Okay, so these will never be visited, so your DFS is incomplete. Okay, so what you would actually do is, you would actually, so suppose I start my BFS on this from node 1. So this would mark visit this and this would also be visited. Okay, and visited for 1, 2, and 3 would be marked as true or 1. Okay, that means these nodes have been visited. Okay, so we would actually like do the DFS on any nodes that are not visited. Okay, so we would start from 1 till the maximum number of nodes. So we would start from 1 to 7 over here. Okay, when we start for 1, then 2 and 3 are marked visited, so we don't do the DFS for it, but we do the DFS for 4. So when we do the DFS for 4, then 4, 5, 6, and 7, all of these nodes are visited. Okay, so here BFS is done 2 times. Is this clear to everyone that here DFS is done 2 times? And here what would be this is actually called connected components. Okay, so here if someone asks you what is the number of connected components, it is actually equal to 2. Okay, that is how many times you call the DFS to traverse the entire graph. Okay, and like is this clear to you guys? So I hope it is clear. Let me just make a very few changes in the code. So what we would actually be doing is we would be doing for int I equal to 1, I less than equal to n, I plus plus. Okay, and then we would checking if the I is not visited, then we would be calling DFS of 1. Okay, so this is the code for D. This is the correct code for DFS. Okay, and if you want to find the number of connected components, then just initialize the count variable, initialize it with 0, and every time DFS is called, just increment that variable. Okay, and in the end, you can print the number of connected components. Okay, so is the code absolutely clear to you guys, as well as the concept of connected components clear to you guys? So we can actually move on to the BFS code, and then we can move on to solving problems. Yeah, correct, Sandeep. So just tell me if this is clear, so we can move on to the BFS. Okay, so clear. Okay, so let's move on to the BFS part. So in BFS, what happens is we traverse things breadth-wise or level-wise. Okay, so let me tell you. Okay, I'll zoom a bit, don't worry. Okay, be basic also. It would be of intermediate level. Okay, but if you have already these would be standard problems. So if you have already been doing standard problems on LeetCode, then I don't think it would be very helpful. Okay, and if you want, then I can show the problems to you that I plan to solve. So first is the number of island problem, which is a very standard problem. Then time needed to inform all employees. So this is actually a tree, and you suppose two is the manager. Okay, and someone tells something to announce it to all of its children nodes. Okay, then what would be the maximum time being taken? Then we would be solving this problem, which is a problem, very simple problem. Okay, all of these are actually medium problems, and this is a concept that if you don't know, then like you can watch the stream. So this is actually based on multi-source BFS. Okay, so these are the problems that I plan to solve, and like I hope it is clear. Like all of these are medium problems, but if you have been doing problems on LeetCode already, then I think this stream will not be very helpful. Okay. Okay, so where was I? Yeah. So I was actually telling about BFS. Okay, so suppose this is my graph. Okay, this is 1, this is 2, this is 3. I'm considering the same graph for simplicity purposes and for the case that I don't have to rewrite the input. Okay, so here let us say I start from node 1. Okay, and this I actually called as level 1. Okay, then those nodes which are actually one edge apart from the first node are actually called to be at level 2. So 2 is a node which is 1 unit apart from node 1. 3 is also a node which is 1 unit apart from node 1. Okay, so these two are actually called level 2 nodes. Okay, then if you see 4 is one node which is actually which is actually two edges apart. Okay, so here you actually can say this is level 0 or this is level 1, and here you can say that it is two edges apart, so you can actually consider it as level 2, and these you can consider it as level 3 since these nodes are actually at a distance 3 unit apart. Okay, like I hope it is clear how I am calculating the distance. So this is 1 unit, this is 1 unit, and this is 1 unit. Okay, and similarly for this. So just tell me if the concept of levels is clear to you guys. Like what do levels actually mean? Okay, so level just tells me like how far apart from the source node, okay, is this node, okay, in terms of number of edges. So the source node, for the source node, this is obviously 0. Okay, for the node that are directly connected to source node, this is actually 1. Okay, and similarly you can calculate. Okay, so I hope it is clear. So what we actually do is we actually implement it using a queue. So the first thing that I do, same concept is here. Okay, we would be using a visited array, so we don't visit any nodes which have repeatedly. Okay, so we would just visit every node one. So I'll just add one. Okay, so first I would add the source node. Okay, then I added one. Okay, then I had pop one. So I popped the topmost node and the frontmost node, and I'll mark it as visited. Okay, and then I'll insert the nodes that are directly connected to it in the queue as well. So here I would insert 2 and 3. Okay, and now whenever I insert, it obviously means like I have visited them. So 2 and 3 have been marked visited as. Okay, so here, here you would see that whenever we insert it, then we actually mark those nodes as visited. Okay, and I will just elaborate more over this, but for now, just understand that whenever I add a node to my queue, then I mark it visited there itself. Okay. So then 2 and 3. So I pop the frontmost node. So here it could be 3 and 2 as well, or it could be 2 and 3. Doesn't matter. Okay. So now I would pop 2 as well. Okay. So I think. Okay. So I did not switch on my chart. Yeah. Okay. Okay. Good. So now I pop out 2. Okay. So now wait from 2. I would check that 1 and 3 have already been marked with it. So I won't do anything for 2. Okay. So it would simply be popped out. Now I would go to 3. Okay, and 3 would say that it is connected to 1, 2, and 4. Okay, but only 4 is the only node which hasn't yet been marked with it. Okay, so I'll pop this node out. Okay, and mark 4 as related and add it to my queue. Okay, so here you can see that first I visit those nodes which are at level 0, then I visit those nodes which are at level 1, then I visit those nodes which are at level 2, and then I finally visit those nodes which are at level 3. Okay, so here we are actually visiting nodes level wise. Okay, so that is why it is called a level order traversal or a breadth first search. Okay, so here you can see this is something referred to as breadth. Okay, so I hope the logic is clear to you guys. So let me move on to the code. Okay, okay, so this thing DFS function I will just remove and let me rename. Okay, so I hope the code is clear. This is the maximum I guess I can do. Okay, so BFS, so you have a function BFS, okay, similar to how you had a DFS function, and you just give it a source. Okay, so you just define a queue. Okay, so in C++, in Java, in every language, you have a queue. Okay, so this is how you define it, and we have discussed quite a lot about it. Okay, so I don't think there is a point of discussing now. So as I told you that whenever I add the node to the queue, I mark it visited there itself. Okay, so then once I have added my source node to the queue, then I will traverse the queue till the point that I still have nodes. Okay, so I'll just do while queue.empty. Okay, while unequal to queue.empty, that is while the queue is not empty. Then I pop the frontmost node by queue.front. Okay, and I'll just print it out. Okay, and then similar to I would traverse the list of the. Okay, so let me keep it as let us say f, since we have already used u. So for int I equal to 0, I less than adjoint of f dot size I plus plus, and let us say int b. I store it over here u comma f. Okay, then I'll just check that if this node hasn't been visited, then I'll add it to my queue. Okay, so queue dot push b. Okay, and I'll mark it visited as soon as I add it to my queue. Okay, so it has been marked one. Okay, so that is I think the code for BFS. Okay, so yeah, this looks cool. Okay, so similar to how we did DFS, if I just call BFS on the node 1, then there would be the same problem that we won't actually be traversing the entire graph. So I'll actually be using the same method. Okay, and visited would still be there, and here the only change would be over. Okay, so let me run this code again. Just a second. There is a runtime error. I can't show. We mark visited you as one. Okay. While q.empty. Okay, so we haven't actually done q.com. That's the reason. I think it should. I think it will work now. Yeah. How are you actually getting 33 and 5? And how are you actually getting 0? Okay, so that is actually okay. 1, 2, 3, 4, 5, 6. Okay, so this one is for the number of connected components that we have printed at the end. Okay, so here we printed the number of connected components, right? So this graph is connected, so the number of connected components would be one only. So here it is 1, 2, 3, 4, 5, 6. Okay, like if you change the graph, you can do like predict whatever the BFS signature would be. Similarly, the logic would remain the same. Okay, this is the code is exactly similar to what we did in DFS. Okay, but only difference is that here we are actually traversing the nodes breadth wise. Okay, level wise. Okay, yeah, it was q.conf. So just tell me if the code is clear to you guys. So I can actually move on to telling you a few more things about BFS before we move on to solving the problem. Yeah, we can find the connected components using BFS also. Okay, but we find the connected components mostly using DFS since DFS is very short to write. Okay, so BFS is slightly longer. So if you remember the code for DFS, it was I think only 3 or 4 lines. But if the code for BFS is actually slightly lengthier. It is almost double the length for DFS. Okay, so let us see one more thing from here. So these levels, let me use some example, are actually the distances from source node. Okay, so these levels are actually distances from source node, shortest distance from source node. So to the shortest distance from source node, that is node 1, to 2 is actually 1. That is at what level it is. Similarly for 3 it is 1. Similarly for 4 it is 2. Okay, and 5 and 6 are at level 3, so for them it is 3. So like this is something that is very obvious from what we can see. Okay, so see one thing. I suppose I am at some node u. Okay, and these are its child nodes. Let us say v1, v2, v3. Okay, then suppose this is the source node. Let us say s. Okay, and one thing. Suppose distance of u. I want to find what is the distance of, let us say, v1. Okay, so if I know the distance of u, I can just write distance of v1 as distance of u plus 1, right? If the distance of node u from s is actually equal to, let us say, distance di this of u, I can just add 1 to it and get the distance for v1, right? Is this very clear to you guys? Okay, so in this way you can find the shortest path. Okay, but here you see that there is a constraint that the edges should be unweighted. Okay, so that is, we can say that they have the same weight, that is of 1 unit. Okay, so the main use of BFS is actually in finding shortest path. So here there would be edge as well. Okay, see by and like let me tell you one more thing. So yeah, DFS we discussed, it is for finding number of connected components. Okay, so using DFS we can't find the shortest path, so we have to write a slightly lengthier code. But we can find the number of connected components using both DFS and BFS. Okay, but since the code of DFS is smaller to write, then we would obviously always prefer to write a DFS for finding the number of connected components and a BFS for finding the shortest path. Okay, so is this very clear to you guys? Okay, so I hope it is very clear to you guys. Okay, and this is a concept that we use very frequently. Okay, so like I'll just make sure that you guys are actually able to understand the entire concept, how we have written this relation, and when do we actually use BFS and when do we actually use DFS. Okay, so this is all about it. Okay, so let me write the distance code as well. So let me have another array, distance array. Okay, and distance of source node is actually equal to 0. Okay, and here we would just write distance of b equal to distance of the node plus 1. Okay, and let us just print it as well over here. For int I equal to 1, I less than equal to n, I plus plus see out distance of that. Okay, so let me just run the code. I don't see any discrepancies in the code. Okay, so I hope it I know it will work, and at least I hope it will work. Okay, so okay. Uh, okay, so I have written distance of B. So I think it will work. Okay, so there is still some issue. Let's just check quickly. So few. Okay, so here we mark distance of U as 0. Okay, and here we just say distance of B equal to distance of U. Okay, so it is actually not distance of U, it is F. Okay, so I'm actually getting confused because I usually don't write as extra function for BFS. I just write it over here. Okay, so that is why I'm confusing the popped up node with U and B. So that is the reason I tell you guys like don't. So yeah, you can see over here that second and third nodes were at a distance of 1 unit. Okay, the third node was at the fourth node was at a distance of 2 unit, and the fifth and sixth nodes were at a distance of 3 units. Okay, so like just tell me if the code is relative, guys. So I'll just tell you one more thing. So just write a yes if the code is relative, guys. Okay, so see one thing. See, I was actually messing up this code, and why was it the case? Because see, if I have in my mind that U I always use for the node that I am currently at, and V I always use for the child node. Okay, so like whenever you write the code, always use this convention. Okay, and like you can name this as X or something. Don't mess it up. So that's what I'm telling you. Like always try to fix things up. Like you would always be my current node, and we would always be that node, which is connected to it using an edge. Okay, so remember this thing. That is why I was actually messing this up. Okay, so this is the distant part. Now, entire theoretical concept of DFS and BFS is covered. Okay, and I hope you guys understand the code as well. Okay, let us quickly discuss the time complexity as well. So both the time complexity for DFS and BFS is actually O of n plus n. Okay, so this is the time complexity, and the space complexity for both of them are actually O of n. Since in BFS you actually use a cube, and in like DFS you may think that why is the complexity O of n. So in DFS you are actually using the stack space. Okay, so that is why the time complexity is O of n, and that is why the space complexity is O of n. Okay, so in both cases, DFS as well as BFS, the time complexity is O of n, the space complexity is O of n. Okay, so you can also think of it like that. See, if you try to implement DFS iteratively, then also you would be using a stack to implement it. Okay, and internally recursion is just using stacks. Okay, to store your function calls. Okay, that is why the space is actually O of n. Okay, yeah, and the n factor would also be there for the related array. Okay, but it is not just for the related array, it is for the stack space as well. Okay, so quite a lot of people think that if we didn't have a related array, then it is O1, but it is not O1 since we actually need to consider the stack space as well. Okay, so let's move on to the next part. That is, let us quickly solve a few questions, few standard questions, and the next topic that we would be covering is actually multi-source BFS. Okay, so the first question, let me zoom it up. So it is number of islands. It is a standard problem, very standard problem, and it is asked very. So the two problems, number of islands and rotting oranges, are actually those problems which are very like frequently in companies like Amazon, Microsoft, all of these companies, and these are very standard problems. Okay, so let us see the first problem, number of islands. So you are actually given a 2D binary grid. Okay, so that means that you would be having zeros and ones only, and one actually represent that there is a land over there, and zero represent that there is water over there. Okay, so Sandeep, how time velocity of n plus m? Okay, no problem. Okay, so since Sandeep, see one thing. uh, Suppose I start my DFS from 1. Okay, and suppose it has two children, let us say 2, 3 and 4. Okay, then I would, let us say I go to 2. Okay, then I would go to its children further. Okay, so suppose I took this path. Okay, and finally that I see that I reach to these nodes, but they don't have any child nodes, so I'll just come back. Okay, and then I'll come back to this, and then I'll again go over here. Then I see that there are no children, there are no nodes connected to 3 which are not visited. Then I would come back. Then I would go over here. Then I see that there are no nodes connected, so I would come back. Okay, so you can see like we are only visiting n nodes and m edges, right? We are visiting each edge twice actually. So once I go over here, then when I come back over here. Okay, so that is why it is O of n plus m. So is it clear to you now? It is quite similar to how you calculate the time complexity for recursion. Okay, you can draw the recursion tree and just by finding what, how many number of states there are, you can calculate the time complexity, right? And in BFS also it is very similar to see that you are only going to some node if it is unvisited. Okay, and you are actually traversing its edges only. Okay, so like if you see that let us say you are at some node u. Okay, and it is connected to let us say so some of you may actually think that the code of DFS was something like this. Yeah, rotten oranges is multi-source BFS. Okay, so in DFS of u, you actually traverse the like adjacency list for u. Okay, so some of you may be thinking it would be n cross n. Okay, but see one thing. We all agree that DFS would be called for 1, 2 till n. Okay, so how many edges are there in the adjacency list of node 1? So there are let us say m1 edges. For m2 let us say there are m2 number of nodes, and let us say for mn there are mn number of nodes. Okay, so when you'd be at DFS 1, you would actually be traversing the list of size m1. When you would be at DFS 2, you would actually be traversing the list of size m2. Okay, so the first n factor is for these nodes that you are actually going to all of the nodes from 1 to n. So that is why the m factor. Then you are actually traversing here for loop runs m1 times, here for loop runs m2 times, here for loop runs mn times. Okay, so what it would be m1 plus till mn. Okay, and what would this be? Okay, this would just be 2m, right? Since for every node u comma v, we know that we add u we would add u to the adjacency list of v, and we would add v to the adjacency list of u. Okay, so I hope it is clear now as well using like normal logic. Okay, so n and 2n actually doesn't matter. Okay. Okay, so where was I was actually, yeah, we were at this problem. Okay, so here you are given, so here you can see the grid. So this is connected till here, it is connected, and this is connected, this is connected, and this is connected. So this is one island. Okay, so you actually have to find how many number of islands there are. Okay, so let me tell you the problem in a very short format. Okay, so let us say you have one over here, one. Okay, one, and then you have a couple of zeros. Then you have a one, let us say one over here, one over here, one over here. Okay, and then you have a couple of zeros. Let us say then you have some ones. Then you have zeros, and then okay. So suppose this is what your 2D binary grid looks like. Okay, and these zeros are actually water places. So here water is present. Okay, so we all know what islands are. Okay, so islands are those places which are actually surrounded by water on all sides. Okay, so here you can see that how we are actually defining. So we can, like, this is a island. Okay, and this is one more island, and this is one island. Okay, so there are three islands in this place. So some of you may think that why is this not connected to this? Okay, so some of you may think this, that why I haven't connected both of them. So in the question, it is usually written that how are they connected. So let me just see how they are connected. So you can see that island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So you can only connect horizontally or vertically. You can't connect them diagonally. Okay. So here if I try to make a connection here, then it is actually a diagonal connection, right? So that is not possible. So that is why I am not considering these two pieces of land connected. Okay. So is the question clear to you guys? Just write yes if the question is clear to you guys. Okay, so like, can you guys think how we can actually solve this problem? This is actually a graph problem. If you consider these cells as actually nodes, so this is, if you consider these cells as actually nodes. Okay, so you can see that these cells are connected by this edge, this edge, this edge. If you can imagine it like this, then you would be able to see that these are actually nodes of a graph. Okay. So yeah, it is just equal to the number of connected components. Okay. So like for those of you who are not able to understand, so see, the cells of the matrix can just be considered. So suppose I consider this cell and I consider this cell adjacent to it. Okay, let me consider all of those cells adjacent. Okay. So I can consider all my cells as actually nodes in my graph. Okay, and how when are two nodes connected? We said that we are connected vertically and horizontally. Okay, and only lands are connected. A land is not connected to a water. Okay, so let us say it is like one over here, one over here, one over here, one over here, zero over here, one over here, zero over here, one over here, one over here. Okay, so we know lands are connected, so they are connected horizontally and vertically. So this is connected to this is connected to this. This is how they would be connected. We know that water and water are not connected, and water and land are not connected. Okay, and whenever lands are connected, they are connected vertically or horizontally. They are not connected diagonally. Okay, so if you see in this graph that if you start applying DFS from, let us say, this node, okay, then you would mark this node as variable, then you would mark this node, this node, this node, this node. So here you get the first connected component, and then finally you would actually start DFS from here as well. So you would get the second connected component. Okay, so here the number of connected components is equal to 2. Therefore, we say that the number of islands is actually equal to 2. Okay. How to tell the brute force solution to this problem? I think this is the brute force solution, right? Like I didn't get like what do you mean by the brute force solution to this? And like if you can elaborate over what the brute force solution is. Okay. So let us see the code for this as well. I did this problem some years back, I guess. Let me just see that if I have submitted the code. Yeah, so I did it in 2020. That's quite some time back. So let's see the code. Yeah, I think we can directly tell the solution. This is a very standard problem. Okay. Oh, what the hell is this? Okay, so I implemented it with union and find. Never mind. Let me see if I have any other. And why on earth would I implement it? Okay, so probably I was just checking my implementation of union and find. Okay, so I think you guys can implement the solution yourself. Also, let me just check if there is some solution present on this that we can see. So let us see this solution. Yeah, so let us see just the DFS solution since we have to count number of connected components. So I have to always told you that to find the number of connected components, always use DFS. Okay. So here we are just traversing over the entire matrix. Okay. And if grade of ij is equal to 1, we can only start DFS or we can only start a connected component when there is a land, right? So then we do island plus plus, that is the number of connected components plus plus, and then we just call our function, call our DFS function. Okay. So here you may see one thing that they have. Okay, so let me discuss the solution first. So here they are actually doing the DFS, and I and j are the coordinates of your current cell that is denoting your node. Okay, so you just call the like DFS on all of it adjacent nodes, and if you ever reach a node which has invalid coordinates, that is I is less than 0, or I is greater than or equal to m, or j is less than 0, or j is greater than equal to n, or it is a water, then you won't actually be traversing this. Okay, and the thing that this is just a normal BFS. Okay, but you may think that why haven't they used a visited array? So what they have done is, whenever they suppose I reached over here, so I would only be able to reach over here if this if the current cell that I'm currently at, if the cell that I'm currently at is actually a land. Okay, so if I just mark it with a 0, when I reached it for the first point time, then when I marked it at 0, then I can never reach it again, right? Since there would be a check. This here we are checking, right? If it is a land or a water. If I mark, whenever, as soon as I reach some place of land and I mark it as a water, then I would never be able to come back again to it, right? So that is why they haven't used a visited array. They have just changed the grid. Okay. So I hope this is clear to you guys. Just write a yes if it is clear to you guys. Yeah. So this is also a very small concept that you can use to get rid of the visited array. Okay, and save on some space. Okay. So that's the solution. Okay, so let us see another problem. So let me directly explain you the problem only. So you are actually given n. So n is the number of employees in the company. Okay, and the employees are having their IDs from 0 to n minus 1. Okay, so here n is 6 and the employees are actually having an ID from 0 to 5. You can see over here. Okay, and this is actually a tree. Okay, that's the first thing. So tree is just a special form of graph, okay, in which the number of edges is n minus 1 and there are no cycles, or we can say that the number of connected components is 1. Okay, so a tree is always connected. Okay, it can't be disconnected, unlike graphs. Okay, so here you can see that head ID is 2. Okay, so what does head ID means is, this person 2 would actually be announcing something. Okay, to 0, 1, 3, 4, 5. Okay, and then they would further announce it to their subordinates. Okay, so similar to how it happens in a company. So let us see, 6 is the manager. So 6 would say something to 5, then 5 would say to 4, 4 would say to 3, 3 would say to 2, 2 would say to 1, and 1 would say to 0. Okay, so between this communication, there is some amount of time gap there that is present. Okay, so here you can see that inform time tells you that how much time the ith person takes to inform its subordinate. Okay, so here you can see that for inform time of 0 is actually, I think, the ith employer needs to inform my manage to inform all its direct subordinates. Yeah. Okay, so cool. So 0% takes 0 amount of time to inform its subordinates, since you can see that it does not have any subordinates. Okay. Similarly, 1, 3, 4, 5. So 1 takes 0 amount of time. 2 takes 1 unit of time. So if 2 wants to tell something to 0, 1, 3, 4, 5, it would take 1 unit of time. So don't think it of like it would tell to 0 first, it would tell, then it would tell to 1, then it would tell to 3, then it would tell to 4, then it would tell to 5. Don't think of it as 5 units of time. Okay, don't think of it as 5 units of time. He would say simultaneously, and every one of his subordinates would listen. So consider this as a sort of a meeting. Okay, so this is the question, and you need to tell me what is the longest amount of time that is required, such that the head person, whatever he says, reaches everyone in the organization. So first, tell me if the problem is clear to you guys. Okay, so here you can see that the answer is 1. Okay, since the second person takes 1 unit of time. So after, so let us say now it is t equal to 0. Then at t equal to 1, he would have told to 0, 1, 3, 4, 5 everyone. Okay, so similarly, let us say this graph. So here you can see that the time would be this time, that is the time 6 takes to tell to 5, then the time 5 takes to tell to 4, 4 takes to tell to 3, 3 to 2, 2 to 1, and 1 to 0. So you would have to sum all of the times over here. Okay, so similarly, you can check out all of the other examples as well. Okay, and you can see that the number of nodes is actually equal to 10 to the power 5. And since this is a tree, the number of edges would just be equal to n minus 1. Okay, so we are expecting a ON solution for this. Okay, so just write your solution in the chat. So someone is saying BFS. Okay, so like how are you going to maintain things using BFS? Time complexity, expected time complexity is ON, since n is of the order 10 to the power 5. We always try to think that can we do it using DFS first, since the DFS code is shorter to write. To track maximum time at each level. Yeah, correct. Okay, so yeah, there is a code for around. So if you guys want, then we can stop over here, and I could take another session. So just tell me like if you guys plan on attending the code process for this. Okay, so yeah, the idea is the same. Okay, so let me just explain the code since you guys are going to get the context. Okay, so here I just made a global graph. Okay, and I'm using a pair since we need to store both the things, that is the node that is connected to and as well as the weight of the edge. Okay, so I'm just passing adding a thing, one more thing called the level. Okay, and I am incrementing level by the weight coordinate every time. Okay, so Pratik, I have an interview tomorrow. Let's think. Okay, so like it depends on you guys. Like if you wanna give the code process context, or like should we just discuss? Just write it out in the chat. I am okay with anything. Okay. So like if you guys wanna know the logic by a diagram or something, then you can see it over here. That suppose this is what your tree looks like. Okay, and suppose let us say it is this is not 4, 3, 4, 1, 2, 3, 3, 1, 2. Okay. So when I am actually calling DFS, I am passing one more thing, that is the depth. So here my depth would be 2. Then here I would add the edge weight. So here it would be 2. Here it would be 3. Here I would add 2 again. So here it would be 5. So we obviously know that the maximum time would be required for the leaf nodes. Okay, so at the leaf node, I can just update my answer. So 5 units of time is required over here. So if you go from here, so here time required would be 3. Here time required would be 7. Okay, so now we will update our answer to 7. So if you come here, time required would be 4. If you come here, time required would be 6. If you come here, time required would be 4. So here time is 4 and 6. And here if you see that 3 plus 3, time required is actually 6. Okay, so the maximum is actually 7. So 7 is our answer. Okay, so we only need to maintain one thing. Okay, that is whatever you call it level or call it anything. Call it level or call it some anything. Okay, and we are actually our graph would actually be stored as vector pair int int. Okay, so the list would so be like this, that suppose I am seeing the adjacency list of 1. So you would see that I would store not just a node in it, but also the weight with which it's connected. So let us say this is node 1 and this is node 2. Okay, and let us say this is node 3. So node 1 is connected to node 2 and having a weight 2. Node 1 is connected to node 3, let us say weight is 5 with a weight 5. So this is how it is stored. Okay, and that is the reason why we need paired support. Okay, so I'll continue. Okay, since quite a lot of your shit. Okay, so I think this was an easy problem. Okay, so uh, let's move on to the next problem. So this is also an easy problem that you guys I think should be able to do. So here the problems that you can obviously Google and submit the code on LeetCode. Okay, so there are n computers numbered from blah blah blah. Okay, so I think as far as I can see, so answer is one over here. Okay, I do connection certain give to directly get and based on to top them directly within the main. So it's a basic question. I think it requires some amount of math. So like you guys can just try this out on your own. Okay. So I think the question is that you can traverse some nodes. Okay. And you have to find the minimum number of connections. You can remove some connection and add it to some other place. I think that's the question. Okay. So you can, okay, no, it is not CC minus 1. Since you only need to add those edges which were previously also present. Okay. So there would be some difference to the form. Okay. So in this problem also you can solve count servers that communicate. Okay, so here the only thing is that I think you are given a grid. Okay, one means cell. Okay, so sir, two servers are said to communicate if they are on the same row or on the same column. Return the number of servers that can communicate. Okay, so these two servers won't be able to communicate, so answer is 0. These two can communicate as well as these two can communicate. So internally, all three of them can communicate. So answer is 3. Here you can see these two can communicate and these two can communicate. So answer is 4. Okay, so I think basically you have to just count the sizes of the connected components with size greater, whose size is greater than 1. Okay, so like is this question is this question clear to you guys? This is also one problem that you can I think very easily solve. Just tell me like if it is okay. Yeah, yeah, yeah. All these problems are very similar. So like you, I think you guys would be able to do most of them on your own. Okay, so let's come to another concept that is called multi-source BFS. Okay, so this multi-source concept is both in BFS as well as it is in Dijkstra. Okay, so uh, it the concept is very similar. Okay, but let me so quite a lot of so in I remember in Uber, the first question that they asked me on Graphs was actually based on multi-source BFS. I'll be discussing that problem as well. Okay, but first let me tell you the concept of multi-source BFS. Okay, so see, suppose you have a graph. Let us say. Okay, so suppose let us say this is your graph. Okay, so suppose let us say this is your graph. Okay, and consider it as let us say these are shops actually, and this could depend on the. So suppose 9 is a place where you get pizza. Okay, and let us say 7 is also a place where you get pizza, and let us say 4 is also a place where you get pizza. Okay, so what you need to do is you need to tell me that if I'm at some place, let us say X. Okay, and I want to get pizza delivered to my house. Okay, then what is the minimum amount of time it can take me? Okay, so minimum amount of time it can take. So assuming that and that time required to travel each edge, let us denote it by TE. It is actually equal to 1 unit. Okay, so suppose if I am at 2, the time is actually 1 unit. Either I can order from 9 or I can order for 4. For 4. Okay, so if you see for 6, if you order from this node, then it would reach in 1 unit of time. If you order from this node, it would reach in 2 unit of time. If you order from this node, it would reach in 3 unit of time. Okay, so the minimum time is actually 1 unit. So is the question clear to everyone? Okay, so now try thinking of a solution. So I think if you guys have understood the concept of BFS well enough, then multi-source BFS is something which is very trivial. Thinking of a solution. First we push 7.9. Okay, then what would you do after pushing? Like, is that the only change that you would make? Apply BFS on C just now. Okay, so if you apply BFS on 7, 9, and 4, do you mean that you would individually first apply from BFS on 7, then from 9, and then from 4, and then you would see that which is having the minimum distance? Uh, then see the distance. Okay, so I think Kushal is on the right track. But Sandeep, your solution is actually would actually run in time complexity O of n into number of pizza centers. We can use an array to store the distances of kth node from x. What do you mean by kth node from x? And like how will it help you? The traverse neighbor of okay, yeah, Kushal, I think your solution is correct. We can do BFS on X and we can store the distance of these nodes on X. Okay, see, but see one thing. We can do BFS from X. Okay, so see, these are actually queries. Okay, so in each query you would be given an integer X. Okay, so like if you try using that approach, then it would be Q into X. I think the solution that you went is actually like running the dfs from X and just checking that what is the distance to the what is the shortest distance to any of the beta centers, right? No, but that solution would give a TLE, right? We try thinking from like very scratch of BFS. How does BFS actually calculate any distance? Just see like how the concept of BFS started. We had some sort of source node, then how we implemented the source nodes. And here the only difference is that you have multiple source nodes. Okay. Try to think of it using just the very basic approach. Okay, so we can do BFS. So Vijay, do you mean you would be doing individual BFS? So suppose first day BFS you would do from here, then you would do a BFS from here, then you would do a BFS from here. So you would be doing three BFS. Do you mean that? Yeah, but see, there can be so suppose n of the out of the n houses there are n minus one are actually pizza shops. So your question your solution would be having a time complexity of n square in that case. Okay, so see, let me tell you the idea behind the problem. Okay, so see, this is very similar to BFS. The only change that is there is we insert all of the nodes which are our source nodes. So let me use green color. So this was our source node, this was our source node, this was our source node. We insert all of these nodes before starting the BFS in our queue. Okay, so in our normal BFS, what we did was we just inserted the source node. But here, the source nodes are actually multiple. So this is actually a search node. This is another search source node. This is another source node. So we actually insert all of the source nodes in our queue, okay, and mark the distances of all of them by a zero. So here also distance is zero, here also distance is zero, here also distance is zero. Okay, based on the order of insertion, any node can be picked by you. Okay, so suppose this node is picked, then you would check its adjacent neighbors. So here you would check, here you would check, okay, and here you would check. Okay, and since we know that when we are using a queue, we actually do level order traverse. Okay, then we would mark the distances of all of these nodes by a 1. Okay, and we will add both all of these nodes in our queue. Okay, so similarly, if you go on doing this, then you would get all of the nodes would only be marked. So see, this node would be marked by this and not by this node. So the distance that would be updated would be from this node only. Okay, so that is why the approach is working. Is the approach clear to you guys? Like when we need to apply multi-sort BFS, okay, and like if you can think of it like if you are trying to find the shortest distance from many such sources, then mark all of those distances of all of those source nodes with a zero and insert them in the queue. Is the logic clear to you guys? Just tell me if the logic is clear to you guys. So see, what the concept of BFS was, we had some source node. From that source node, we marked its distance as 0 and then traversed nodes breadth-wise, okay, from that node. And that actually gave us the distance. What we are doing over here is we have multiple such nodes. We mark all of those nodes distance as 0 and then we add them to the queue and then start our breadth first search. Okay, here also that it would work in the same manner, but the only thing is that we would be finding sorted distance from all the source nodes, the exact thing that we did in BFS. Okay, so see one thing, like you can try some examples as well, that will also help you, but let me tell you one thing. Okay, so what we did in normal BFS was, okay, so what we did in one source BFS was add all, okay, so there was only one source node, add S1 to Q, okay, and mark distance of S1 as 0. The only difference that is there in finding the distance from one source node to, let us say, k number of source nodes, the only difference that is there is add all nodes from S1, S2 with Sk to Q. Mark all their distances as d of S1 equal to d of S2 equal to d of Sk as 0. Okay, so what you do is you just mark all of the distances as 0. So this is the only difference. Okay, and how does it work is, see, the first thing that you guys need to understand is BFS is the best breadth first search. Okay, so what you do in BFS is actually you traverse nodes level wise. If there is only a single source node, then you would be traversing it level wise. This you already know. But if there are multiple source nodes, okay, so suppose there was only one source node and this was the node. Okay, then first you would traverse all of the nodes that are at distance 0. Then you traverse all of those nodes that are at distance 1. Then you would traverse all of those nodes which are at distance 2. Okay, so see one thing, that nodes are traversed in sorted order of distance. The same concept you apply over here. Suppose these are our source nodes, so I would add them to my queue, and again the nodes would be traversed in sorted order of distance. The first node that would be inserted would be those nodes that are connected to these nodes. Okay, and their distance would be marked as 1. Then the next set of nodes would be marked as 1. Okay, so that is how it is working. So is it clear now? Okay, like if you see that suppose there is some edge, okay, which is let us say directly connected to it, and this is let us say A and this is let us say B. So and this node let us call it as C. So we can see that C and B are connected using two edges, three edges actually. But it is C is connected to A using just one edge. Okay, and what did I tell you? In BFS, nodes are traversed in sorted order of distance. So C would be marked by this node A and not this node B. Okay, so the distance of C would be updated by the distance of A. Since in BFS we are traversing nodes in the order of their distance, in the sorted order of their distance from the source node. Is it clear now? The change that we need to make from the like normal code as well as the logic why we are actually doing this. Is this clear to everyone now? Just write a yes if it is clear to you now. Like write no, don't write a yes, write a no if it is not clear. Okay, so if it is not, then just write it out. Meanwhile, let me discuss a question. So this is a question that was asked in Amazon. Okay, so many companies, quite a good number of companies ask questions on multi-source BFS. Okay, so don't think of it as something very hard and don't skip it. Okay, like many companies, Amazon, Microsoft, all of these companies very easily ask question on these topics. Yeah, yeah, Sandeep, exactly. Whichever node, see, suppose this node is closer to some node U and farther from some node V. So you would make this node as visited, okay? And whenever we may mark the node visited, we update its distance there itself, okay? And we would reach it later since we traverse the node bitwise, right? Okay, so this was a problem asked in Amazon. This is a very easy problem, first of all. Okay, let us just discuss the problem. So you are actually given a, let us say, grade. And in this grid, at some position, bombs are placed. Okay, so let us consider this position. So suppose a bomb is placed over here. And let us say a bomb is placed over here. Let me make it slightly bigger. Okay, so suppose this is what your grid looks like. Okay, and these are actually bombs. Okay, consider these are actually bombs and this is your grid. Okay, so how the bomb actually blast is, suppose this is bomb. So in the next 1 second, this part, all the adjacent part, both the horizontally, vertically, as well as the diagonally adjacent. Okay, it will destroy this till here. Okay, and in the next second, it would destroy all of those parts which are at two unit distance from it. So all of this would be destroyed. Similarly, simultaneously, all the other bombs will also be working. So this bomb would actually destroy till here in 1 unit of time, then till here in 2 unit of time. This bomb would have destroyed till here in 1 unit of time, and everything till here in 2 unit of time. Okay, so you need to tell me what is the minimum amount of time required to blast the whole grid. Is the question clear to everyone? There are bombs present at multiple locations. You need to tell what is the minimum amount of time required to blast the whole grid. Here, I think the time is actually 4 units. So after 4 units, these nodes are actually at a distance of 3, 3, 3. So they would all have blasted. Okay. These would. Okay. So I think it would be 5 units, I guess. 4 or 5 units. You can find the answer yourself. Okay. So try to think of a solution now. And keep track how many self blocks as soon as the answer is removed from you. Check it. What do you mean by last cell is removed from the queue? Okay, so Vijay, from where would you find the maximum distance? Yeah, correct, Vijay. Correct, Vijay. Exactly. Okay. So see, what we would do is we would consider all of the bombs as our source nodes. So this is, let us say, source one. This is, let us say, source two. This is, let us say, source three. Okay. And find the distance of all of the blocks, all of the cells. Okay. And your answer would actually be the maximum distance, okay, of the endpoints. Time required to reach the for the bomb blast to reach the boundary cells. Okay, so your answer would be the maximum of all of it. Is this clear to everyone? Is the solution clear to everyone? This problem was, I think, very recently asked in Amazon. Yeah, we are doing it using a multi-source BFS. Okay, so no bridge and articulation points aren't asked in interview. Okay, so I hope the solution is clear to you guys. Okay, so if you guys have any doubts, you can ask. Otherwise, that's all for this session. Okay, let me. So this is a problem very similar to the problem that I just told you guys. So 0 represents an empty cell, 1 represents a fresh orange, and 2 represents a rotten orange. And every minute, so suppose there is some rotten cell over here, it destroys all of the cells close to it. Okay, and you need to tell what is the minimum number of minutes till the point that every cell which was fresh, every all of the oranges are actually rotten. So do we take back of this to power this? Okay, so we would create a distance matrix, right? Distance n cross n. So where distance of ij would represent the shortest distance to the I comma j axis. So is there any other concept in DFS which is similar to multi-sort BFS? No, since DFS is mainly used for finding the number of connected components. Okay, so there is no such concept in DFS, but there is one such concept in Dijkstra, multi-source Dijkstra we call. Okay, I'll share. Just write it out in the. So, any other doubts? So, yeah, next class we can either do on, uh, I guess, Dijkstra or MST, any of the top. But BFS and DFS are actually the core concepts. If you understand these, then I think they are good enough. So, I plan on taking a class on topological sort and MHT, Dijkstra. Questions aren't asked much on MHT. Okay, but questions are very frequently asked in good companies on Dijkstra as well as topological sort. And like topological sort is something if you are interviewing in any very good product based company, there is like a 50 to 60% chance that a topological sort question would be asked. Okay, so please solve that. Okay. So it's on lead code, right, Pratik? Okay, so see, let me tell you very nice thing on lead code. Okay, so it's on lead code. Just a second, let me tell this. Uh, So you can just go to discuss, okay, and like you can search by company tag over here. So suppose I want to find the questions for Amazon. So I'll just add Amazon and check in the first link. And here you can see that these. So this is the interview experience from June 29, July 3, June 28. Okay, so here you can get to know everything which is going on. So if you may have, you may be knowing about some other sites as well. Okay, but they aren't really good because they aren't much updated. But here you can see that the experiences are from July 3, June 29. That is, I think, the maximum that you can get. Okay, they shared out questions asked like online coding rounds as well as those asked on site, what compensation they were offered. Okay, everything they share out. So I think you should definitely check this out. Lead code, the discuss section on lead code. Sir, please give some medium level questions on today's discussion. Yeah, I'll give that. Okay. So is it on lead code or carrier gap? Oh, let me just search. So what the problem was? Acid phase, water, flow. uh, I think this is the problem. Oh, is this the problem? It's on lead code. Or is there some other problem on carrier? Okay, so find least cost of 1 to n in graph such that cost of 1 to x is cost of 1 to y minus x to y. Aditya, let's come to your question after this. I'm not able to understand your question for now. Okay, so give me a minute. Let me just read the question. The Atlantic Ocean, that is why it's right and left. The height is partitioned into a grade of squares. You are given a matrix n person. Okay. Height. Okay. So this, I think this is just matrix of ij depends the height either indices or autonomous. No. Okay. So okay. Return a 2D list of grid coordinates. Isn't where is rainwater can flow from cell. Return a 2D list of grid coordinates. Result where result I equal to RICI denotes that rainwater can flow from cell RICI. Like, what is this last line meaning? Do you have to return all of those coordinates where from which water can reach both Pacific and Atlantic Ocean? Atlantic Ocean, not Atlantic Ocean. Yeah. Okay, cool. So I think I understand the problem completely now. So yeah, here you can find. So, but how do you reach Pacific is a 4, 3, 2. Okay, cool. So here, if you see this example, so if you are at this position, then you can go to Atlantic and Pacific directly. If you are at 4, you can go to Atlantic, and if you want to go to Pacific, 4, 4, 3, cool. Okay, so if you are at this position 4, 3, then here 4. So we can go to the same level positions as well, less than or equal. Okay, cool. So similarly, 5, 5, 3, 2, 5, 3, 1, 7, 7. Okay, so you can. Yeah, okay. I think I got the. Okay, so I think we can just like, uh, can't we just do a DFS from, so like the basic approach that I can currently think of is just we can do BFS from all of the nodes. So we can do BFS from one, and we would only be going to those cells whose height is actually greater than the height that we are currently at. Okay, and we can just check if we reach the top and left boundary. If we reach that, then yeah, we can reach Pacific Ocean. If we reach the right and the bottom boundary, then we can reach the Atlantic Ocean. But I think the time complexity would not be very nice. So if you apply DFS for every cell, so there are n cross m cells, and DFS would again take n cross m. So time complexity would be n square into n square. So that would be a time complexity if we start checking from every cell that whether it is possible to reach Pacific Ocean or Atlantic Ocean or not. So let me see the constraint. So 200, 200. Okay, so I think it would be greater than 10 to the power 8, right? So I think this solution will not pass. But like, just tell me if this solution is clear to you guys. Yeah, correct. Okay, so the actual logic of this solution is, see, you can either check from the cells in the grid, see whether you can reach the Pacific Ocean or the Atlantic Ocean, or the Atlantic Ocean, or you can do the reverse. You can start from the Pacific Ocean or the Atlantic Ocean. So we know one thing, that let us see how many cells can we reach from the Pacific Ocean. Okay, so there would be some cells. What all cells? So these cells, the boundary cells, they can definitely reach the Pacific Ocean. These cells can also definitely reach the Pacific Ocean. Okay, so we can start from these cells, the boundary cells, the top boundary and the left boundary cell. Okay, then from every cell we would go only to that cell whose value is actually greater than our current cell's value. Okay, we are actually trying to implement the reverse logic. Okay, so here can I go to 2? Then yeah, I can go to 2. So I would either go from 1 or this 2. Okay, so similarly I can perform a BFS by BFS or a DFS, anything So by inserting the boundary cells and find out those cells which are reachable from the Pacific Ocean. Okay. Then I can also similarly find those cells which are actually reachable from the Atlantic Ocean. Okay. Then I can take the I think intersection of both of them. Okay. So is it clear now? Okay. Cool. So Atish is cost of going from 1 to 5 means like there is an from 1 and 2 and 5. So overall cost of 1, 2 minus cost of 2, 5. Cost of going from 1 to 5 means like there is an from 1 to 2 and 2 to 5. The overall cost of going 1 to 2 minus cost of 2 to 5. So if there are three edges, what would you do? Like how do you subtract the edges? So we can discuss. I can keep a problem session on DSU as well. Okay, but I think we can keep that once we are done with graphs. So there are actually very nice problems on DS. And like if you want, I can give you a problem that you can try yourself, and then that we would obviously be discussing. So if you want, I can give you a nice problem. If you want to try some problem, it is a nice problem and it is not very straightforward, and it is not very intuitive to come up with as well. Okay, for three same. Atisha, I think like I'm not able to understand your question. Like, can you like? I guess you can just ask it in the Telegram group. Like, if you can share some link or anything. So, any other doubts that you guys have? Is it given? What are you asking? Like, what is given? Okay, okay, you are. So, 1 minus 3 equal to 10. 3 minus 4 equal to 1 minus 4 equal to 10. 3 minus 4. I am not able to understand. Like, if anyone is able to understand, can someone just write it if they are able to or you can just post it out in the Telegram. Yeah, you like I can provide you a list. But like if you plan on, okay, so let me see. And where did this by? So graph problems are actually present at three places. I don't know how lead code is functioning, why is it working. So I'll just add them. So what I was telling was you can there are three places where you can solve graph problems from. Okay, so first is just like search the graph tag, and second is the BFS tag and the DFS tag. Okay, so problems are present at three places. Okay, so don't just go for the graph tag. Okay, and I will be adding the problems in the list as well. So any doubts if you guys have, otherwise we can. I let's end this stream. Okay, so I'll be pushing the update for the next class soon. Okay, so that's all for this class. Good night to all of you.